Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Internet Control Message Protocol, or ICMP, plays a foundational role in the operation and troubleshooting of IP networks. Unlike protocols that are designed to carry user data, ICMP exists to deliver control, error, and status information between devices. It acts as the network's internal messaging system, alerting devices when issues arise and enabling diagnostic tools to function. For professionals preparing for the Network Plus exam, understanding ICMP is crucial. It is embedded in many of the exam's troubleshooting scenarios and supports tools like ping and traceroute, which are essential for verifying connectivity and isolating network faults. ICMP functions as a companion to the Internet Protocol, working at the network layer to deliver messages about problems with packet delivery. When an IP packet cannot reach its destination, or if some other routing issue occurs, ICMP is used to communicate this back to the sender. These messages do not carry application data, rather, they inform devices about problems such as unreachable hosts, timeouts, or routing inefficiencies. ICMP is not used for transporting files, browsing the web, or sending emails. Its only function is to support communication between networked devices by signaling issues and delivering feedback about packet handling. The most widely recognized use of ICMP is the ping command, which relies on ICMP echo requests and echo replies. A ping sends an echo request, which is an ICMP Type 8 message, to a destination host. If the host is reachable and configured to respond, it replies with an echo reply, which is an ICMP Type 0 message. This process measures the round-trip time between the sender and the destination, giving a basic indication of latency and availability. The presence or absence of an echo reply is often the first clue in diagnosing a connectivity issue, making PIN one of the most essential commands for network professionals. Traceroute builds upon ICMP to identify each hop along the path between a source and a destination. It operates by sending packets with incrementally increasing time to live, or TTL values. Each router along the path decreases the TTL by 1, and when the TTL reaches 0, the router returns an ICMP time exceeded message. This response includes the address of the router, allowing the sending device to map the route to the destination. Traceroute continues this process until it reaches the final target. If there are routing loops or unreachable segments, traceroute helps pinpoint where the problem lies. Another important ICMP message is the destination unreachable message. When a router or host cannot deliver a packet to its intended destination, it may send back this message to inform the sender. This can occur for several reasons. The host may be down, a required port might be blocked, or a network segment may be unreachable due to a configuration issue. Destination unreachable messages include a code that specifies the cause, such as network unreachable, host unreachable, or port unreachable. These messages are helpful when diagnosing firewall rules or path failures in layered network architectures. ICMP redirect messages are used to inform a host that there is a better route to a destination than the one it attempted to use. For example, if a router receives a packet from a host and knows that another router on the same network is a more appropriate gateway for that destination, it may send an ICMP redirect. This message updates the host's routing decision. However, redirect messages are rarely seen in modern networks due to the security risks they pose and the widespread use of dynamic routing protocols that manage route optimization automatically. To protect network infrastructure from abuse, many devices apply rate limiting to ICMP traffic. This limits how many ICMP messages a device can send or respond to within a certain time frame. Rate limiting helps prevent denial of service conditions caused by malicious or accidental flooding of ICMP packets. However, these limits can also reduce the visibility of diagnostic tools like ping or traceroute, particularly during high traffic periods. For exam questions, it's important to understand that reduced or missing ICMP responses may not always mean the host is unreachable. It could simply be limiting its replies. ICMP operates differently from Transmission Control Protocol and User Datagram Protocol. It is not a transport protocol and does not use port numbers. It is connectionless and stateless, which means that it does not establish a session or maintain any context between messages. Instead, it sends single messages that report on the status or behavior of IP packets. This stateless nature allows ICMP to be used quickly and efficiently by devices that need to report problems or respond to diagnostic requests. Recognizing this distinction helps eliminate confusion when comparing ICMP to application-focused protocols like HTTP or DNS. In IP version 6, ICMP functionality is expanded and known as ICMP version 6. It is an essential component of IP version 6 and supports functions that were handled by other protocols in IP version 4. For example, ICMP version 6 replaces the address resolution protocol by handling neighbor discovery. It is also used for stateless address auto configuration, or SLASC, and for receiving router advertisements. Because ICMP version 6 is required for core IP version 6 operations, blocking it can cause connectivity problems, even when basic IP version 6 addressing appears to be configured correctly. While ICMP is extremely useful, it also introduces certain security concerns. Because it provides information about network structure and device behavior, it can be used by attackers to gather intelligence about a target network. Tools that scan for live hosts often rely on ping, and traceroute can reveal internal device addresses and routing paths. Additionally, certain types of ICMP messages can be exploited for denial of service attacks. As a result, many networks limit or filter ICMP traffic at the edge, allowing only specific types or blocking ICMP from untrusted sources. These practices help secure the network without entirely disabling essential diagnostics. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Firewalls often block ICMP traffic to enhance network security, but this can interfere with diagnostic tools. When ICMP echo requests or time-exceeded messages are blocked, tools like ping and traceroute may fail or produce incomplete results. This can make it more difficult to diagnose connectivity issues or determine the reachability of a remote host. However, some firewalls implement selective blocking, allowing certain types of ICMP messages while filtering others. For example, echo requests might be blocked to prevent scanning, while destination unreachable messages are permitted for operational visibility. On the exam, you may be asked to analyze scenarios where ping or traceroute behavior is affected by filtering policies. Path Maximum Transmission Unit Discovery, or Path MTU discovery, is another important function that relies on ICMP. When a device attempts to send a packet that is too large for a link along the path, and the packet cannot be fragmented, an ICMP message is sent back to the sender. This ICMP message is known as a packet too big message, and includes the maximum size that can be transmitted. The sender then adjusts the packet size and retries. This process is essential for maintaining efficient routing and preventing fragmentation transmission failures. Blocking these messages can cause connections to hang or silently fail when large packets are dropped. ICMP messages are classified by type and code. The type identifies the category of the message, such as echo request, destination unreachable, or time exceeded. The code provides more specific information about the reason. For example, a destination unreachable message includes different codes to indicate whether the issue is a network unreachable, host unreachable, or port unreachable condition. These numeric values are defined by the IETF and are standard across devices. Familiarity with these codes is helpful when interpreting tool output during diagnostics and is sometimes referenced in exam questions that describe specific error types. Using ICMP for troubleshooting involves more than just sending a ping. Administrators can use ping to confirm whether a host is up, whether packets are being lost, or whether round-trip times are excessive. Traceroute provides a visual map of the path packets take, which can highlight where a failure or delay is occurring. When a destination is unreachable, examining the type and code of the ICMP response helps identify whether the problem is with routing, port filtering, or host availability. These tools are part of every technician's basic toolkit and feature prominently in both exam content and real-world procedures. Many network monitoring platforms use ICMP as part of their operational checks. By periodically sending echo requests to key devices, these tools can determine whether systems are reachable and responsive. When a device fails to respond to multiple ICMP pings, the monitoring system may raise an alert. Some tools also incorporate visual traceroute graphs to map out network paths and detect route changes or increased latency. These features provide administrators with continuous insight into network health and help identify problems before users are affected. On the exam, you may be asked to identify which monitoring method relies on ICMP. ICMP can also be misused in denial-of-service attacks. For example, a Smurf attack involves sending ICMP echo requests to a broadcast address with the source address spoofed to that of the victim. This causes all devices on the network to respond to the victim at once, flooding it with traffic. Another example is a ping flood, where large volumes of ICMP echo requests are sent to overwhelm a target. To protect against these threats, networks implement rate limiting, where devices restrict the number of ICMP messages processed per second. Firewalls and intrusion prevention systems also monitor for unusual ICMP patterns that suggest abuse. Logging and alerting on ICMP activity allows network administrators to detect reconnaissance attempts and suspicious traffic patterns. For instance, an unusually high number of echo requests from a single source may indicate scanning. Repeated ICMP unreachable messages could suggest misconfigured routing or firewall rules. Logging systems can track these events and forward them to a central server for analysis. Alerts can be configured to trigger when thresholds are exceeded, helping teams respond quickly to potential threats or misconfigurations. These monitoring practices are not only useful for security but are also aligned with standard diagnostic procedures. The Network Plus exam frequently tests understanding of ICMP functions and how they apply to real-world situations. You may be asked to identify what tool uses echo requests, explain why a traceroute stops at a specific hop, or analyze why packets are not reaching a destination. Some questions focus on security, asking which protocols should be filtered, or how ICMP can be exploited. Others may require you to match message types to their meanings. A solid grasp of ICMP behavior, including its limitations and uses in IP version 6, will help you answer these questions accurately and confidently. To summarize, ICMP is not used for sending data between users, but is critical for delivering status and error information between devices. It powers tools like ping and traceroute, supports functions like neighbor discovery in IP version 6, and helps identify and diagnose network problems. Although it is often filtered for security, it remains an essential part of both IP version 4 and IP version 6 operate. For the exam and for effective network troubleshooting, you must understand ICMP's structure, message types, use cases, and potential vulnerabilities. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.